Today let's we discuss about the off plate. These are the retarding plates. This is the syllabus come under the physics 4th of Dawnere University. Come under the chapter polarization. It is the session number 5. Let's we discuss about this of a plate. How these plates will behave, how they are constructed. So usually you know that polarization is the restricted the vibrations of a particle in one direction. So it allows only perpendicular directions in whatever it may be. The unpolarized light into convert into polarization means unpolarized light have a different way of vibrations, but it's restricted only one part of its vibrations will be sent to the next one, and this may be a linear polarized means in a straight line, or it may be a circularly polarized means the polarization may be circular, or it may be a elliptical polarization. So this type of, and we can be rotate the plane of polarization to another extent with the help of a wave plate, or called another name is retarder. So these are the optical devices which alter the state of the polarization states ಅನ್ನ ಇದು change ಮಾಡುತ್ತೆ. So polarization ಈ ಕಡೆ ಇದ್ರೆ it may be changes to some other angle, or completely like this, or completely like this. So it can rotate its state of polarization, so through which it is light is traveling through it. So these are called wave plates. Depending upon the phase difference, we will be, they have two types of wave plates. We see the half wave plates and quarter wave plates. This topic is included in this chapter, that's why there is only a full wave plate is also there. So these half wave plate and quarter wave plates, they behaves like a retarder, so change the states of the polarizations. So whereas half wave plates shift the polarization directions of the linear polarized light ಏನಿದೆಯೋ, ಸೊ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ನಲ್ಲಿ ಇರುವಂತಹ ಲೈನ್ ಅನ್ನ ಸೊ ಚೇಂಜಸ್ ಡೈರೆಕ್ಷನ್ಸ್ ಯಾವ ರೀತಿ ಬೇಕೋ ಆ ರೀತಿ ಡೈರೆಕ್ಷನ್ಸ್ ಅನ್ನ ಚೇಂಜ್ ಮಾಡುತ್ತೆ. ಸೊ ಈ ರೀತಿ ಇರುವಂತದ್ದನ್ನ 45 ಡಿಗ್ರಿನಲ್ಲಿಯೋ 90 ಡಿಗ್ರಿನಲ್ಲಿಯೋ ಅಥವಾ 180 ಡಿಗ್ರಿನಲ್ಲಿನೋ, ಸೊ ಈ ರೀತಿ ಲೀನಿಯರ್ ಪೊಲರೈಸ್ ಲೈಟ್ ಅನ್ನ ರೊಟೇಟ್ ಮಾಡುವಂತದ್ದು ಈ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್ ನಲ್ಲಿ ಬರುತ್ತೆ. ಅದೇ ಕ್ವಾರ್ಟರ್ ವೇವ್ ಪ್ಲೇಟ್ ನಲ್ಲಿ ಆಗಿದ್ದೆ ಆದ್ರೆ, ಸೊ circularly polarized light and a linear polarized light, and it converted into circularly polarized light, or it can be converted into elliptical polarized light. ಅದನ್ನ ಎಲಿಪ್ಟಿಕಲ್ ಶೇಪ್ ನಲ್ಲಿ ಇರುವಂತಹ ರೀತಿಯಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಿಕೊಡುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕ್ವಾರ್ಟರ್ ವೇವ್ ಪ್ಲೇಟ್ ನ ಒಂದು ನೇಚರ್. ಸೊ ಇದನ್ನ ಹಾಗಾಗಿ ಇದ್ರ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡುವಂಥದ್ದು ವೆರಿ ನೆಸೆಸಿಟಿ ಇದೆ. ಹೇಗೆ ಈ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್ಸ್ ಅನ್ನ ಪ್ಲೇ ಮಾಡುವಂಥದ್ದು, ಹೇಗೆ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಮಾಡ್ತಾರೆ ಅನ್ನುವಂಥದ್ದನ್ನ ನೋಡಿದೆ ಆದ್ರೆ, ಸೊ ಇಲ್ಲಿರುವಂತಹ ಲೀನಿಯರ್ ಪೊಲರೈಸ್ಡ್ ಲೈಟ್ ಅನ್ನ, ಸೊ ಇಟ್ ಚೇಂಜಸ್ ಇಸ್ ಫೇಸ್ ಇರುವಂತದನ್ನ ರೊಟೇಟ್ ಮಾಡಿದೆ ಆಫ್ಟರ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದಿಸ್ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್. ಹಾಗಾದ್ರೆ ಹೇಗಪ್ಪ ಇದು ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್ಸ್ ಅನ್ನ ಇದು ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ, ಏನಿಲ್ಲ, ಜಸ್ಟ್ ಸಿ ಇನ್ ಪ್ರೀವಿಯಸ್ ಸೆಷನ್ಸ್ ಯೂನಿಆಕ್ಸಿಯಲ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ಅನ್ನುವಂಥದ್ದು ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. ಸೊ ಆ ಯೂನಿಆಕ್ಸಿಯಲ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ನಲ್ಲಿ ಏನಿದೆಯೋ ಅದರ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್ ಏನಿರುತ್ತೋ, ಈಗ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್ ಈ ರೀತಿ ಇದೆ ಗೊತ್ತಲ್ಲ, ಈಗ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್ ಇರುವಂತದ್ದು ಈ ರೀತಿಯಿಂದ ಹಿಡಿದು ಈ ರೀತಿಯಾಗಿ ಇದೆ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್. ಇದಕ್ಕೆ ಪ್ಯಾರಲಲ್ ಆಗಿ ಏನು ಈ ರೀತಿ ಇತ್ತೋ, ಸೊ ಈಗ ಬರ್ತಾ ಇರುವಂತಹ ಒಂದು ಇದಿತ್ತು ಅದನ್ನ ಪ್ಯಾರಲಲ್ ಆಗಿ ಕಟ್ ಮಾಡುವಂಥದ್ದು. ಸೊ ಪ್ಯಾರಲಲ್ ಆಗಿ ಇರುವಂತಹ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್ ಈ ರೀತಿ ಇರುವಂತದ್ದನ್ನ, ಸೊ ಈ ರೀತಿ ಇರುವಂತದನ್ನ ಪ್ಯಾರಲಲ್ ಆಗಿ ಕಟ್ ಮಾಡುವಂಥದ್ದು ಆ ಯೂನಿಆಕ್ಸಿಯಲ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ಅನ್ನ. ಆ ಪ್ಯಾರಲಲ್ ಕಟ್ ಮಾಡಿರುವಂತಹ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್ ಪ್ಯಾರಲಲ್ ಆಗಿ ದೇ ಪ್ರೊಡ್ಯೂಸ್ ದಿ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಆಫ್ ಪೈ. ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಪೈ ಅನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುವಂತದ್ದು ಇರಬೇಕು, ಆರ್ ಅಥವಾ ಫೇಸ್ ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ಲ್ಯಾಂಬ್ಡಾ ಬೈ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುವಂತಹ ಇದ್ರೆ ಅಂತಹ ಆರ್ಡಿನರಿ ಅಂಡ್ ಎಕ್ಸ್ಟರ್ನಲ್ ರೇಸ್ ಅನ್ನ ನಾವು ಇಲ್ಲಿ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಾಟ್ ಇಸ್ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್? is a plate of doubly refracting uniaxial crystal. Doubly refracting should be produced and uniaxial crystals should be uniaxial crystal, that is quartz or calcite like this one, whose refracting faces in refract face that reactive face cut parallel to the directions of optic axis. Optic axis na direction ಗೆ parallel ಆಗಿನೇ ಕಟ್ ಮಾಡಬೇಕು. ಸೊ ಹೇಗೆ ಕಟ್ ಮಾಡಬೇಕಂದ್ರೆ to produce it does not depend upon the material on which it made. So it is only depend upon the its thickness ಅನ್ನೇ ಇದು ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಈ thickness ಇರುವಂತದ್ದನ್ನು thickness ಮೇಲೆನೆ ಡಿಪೆಂಡ್ ಇರುವಂತದ್ದು. ಸೊ ಇದರ ಲೆಟ್ ಯು ಡಿರೈವ್ equation for thickness of a half wave plate. Here is the half wave plate. It is a half wave plate. This is the half wave plate. So let the thickness d be the thickness of the half wave plate. So and refractive index respective of the ordinary ray and extraordinary ray taken, let it be mu o, and mu is the refractive index for the ordinary and extraordinary rays. So then for normal incidence, the path difference introduced between ordinary and extraordinary ray is given by path difference is equal to d is the thickness, here not diameter, d is the thickness, into mu naught minus mu, the difference between their refractive indices of ordinary and extraordinary rays for negative crystal, mu naught minus mu for negative crystal, and mu u minus mu naught is for positive crystals. If you use positive crystal, negative crystal, so path difference is equal to d into mu naught minus mu e for negative crystal. If you consider negative crystal, this is the path difference. D into mu e minus mu naught for the positive crystals, because the refractive index of external ray is more than the refractive index of ordinary ray. That's why it is for positive crystals. So even though there is the path difference of the half wave plate is produced by lambda by 2, that's why it is called half wave plate. The path difference is lambda by 2, hence it's a half wave plate. It has half of the wavelength, that's why it is called half. So calculations for the half wave plate, that is for a negative crystal, the phase difference is path difference is lambda by 2, that is d into mu naught minus mu is equal to lambda by 2. For if you take it negative, then d is equal to, usually on simplify we get the lambda by 2 into half of its lambda by difference of their refractive indexes. For similarly for the positive crystals, we can for the positive crystal, that is d into mu e minus mu naught, that is d is equal to lambda. So when the here is the we are using the plane polarized light is allowed to pass through this half wave plate, the emergent light is also be plane polarized, no doubt. If you pass a plane polarized light through this half wave plate, but for all orientations of the plate with respect to the plane of vibrations of the incident light, so but the directions of the incident light is inclined at an angle with that of incident of vibration. 2 theta is the angle of between the directions of vibration incident light and the optic axis will be exit wave plate. So these are the restricting the state of the polarization, that is called retarding plates. That's why the combinations of both the quarter wave plate and half wave plate is called retarding plates, because they retard the motions of the one of the beams motions are restricted, that's motions. So about the uh, of a plates, what is of a plates, derive the equations for the thickness of the of a plate for the positive as well as negative crystal. There is only difference is the refractive indices. I hope you all understand very well. Thank you very much.